Hello, I'm Kristiina Jokinen. I'm going to talk about integration and interaction of trustworthy AI in a virtual coach and give an overview of EU-Japan collaboration on elder care. This is joint work with my colleagues Keiko Homma, Yoshio Matsumoto, and Ken Fukuda, and we are all from the National Institute of Advanced Industrial Science and Technology. Here is a short overview of my talk. I will first introduce the topic here of active and healthy aging by talking about virtual coaching and the e-VITA project. I will then present the e-VITA virtual coach, focusing on the system overview, interaction, integration, and standardization, and finally say a few words about trustworthy AI. In the context of active and healthy aging, AI technology has impact on the human life. It provides innovative solutions to improve human well-being and quality of life, and applications are being developed to address big challenges in the current society: demographic changes, environmental changes, and changes into work, transportation, etc. However, applications don't usually support spoken interaction, and they can't be easily customized to individual needs. Also, integration of various devices and sensors, data sharing, and ethical issues are not always sufficiently considered. But what are virtual coaches? Coaching in general is to support people's learning, growth, wellness, self-awareness, career management, and behavioral change. According to Comhurst, an e-coaching system is an artificial entity that has ability to observe the human behaviors and use these observations as the basis of our conversations, which are aimed at managing and planning the user's goals and supporting their well-being. Such e-coaches have challenging qualities, and the minimal set of features consist of a social ability to engage in ongoing conversation with the user and credibility to be perceived as having expertise and being trustworthy. Moreover, such a coaching system should be aware of its context to stimulate ideas and actions and have learning ability to ask pertinent questions, give feedback, and give advice that is tailored to the individual users. It should also be able to interface with different types of data streams and gather data from user input, measurements of physical activities, self-reports, etc., and be proactive to initiate interactions with the user in order to stimulate these actions, provide reminders, issue warnings, etc. But most importantly, it should have a model of a behavior change to support coaching activities and not only act as a mere instrument, but behave as a coach. This also means that it should be able to develop strategies for behavior change and guide the user in this process, be capable of planning of future directed intentions. Recently, several Horizon 2020 projects have also focused on virtual coaching. For instance, an Empathic project implements coaching through a virtual conversational agent, and the system provides personalized advice and guidance. Another project, Nestor, developed a virtual coach to sustain motivation to remain healthy, while the project Captain and Sam focus on developing personalized virtual coaches to assist elderly people living independently. In Japan, as part of the Cabinet Office's plan Dynamic Engagement of All Citizens, several projects have also studied issues how to maintain and improve the quality of life for old people and support their independent life. For instance, the NEDO Future AI and Robot Technology Research and Development project focused both on basic research to develop core technology and on social implementation, which aimed to solve concrete problems by the next generation AI technology. The Mehdi Ahmed project, development and introduction of robotic devices for nursing care, aimed to develop prototype nursing care devices and evaluation methods for safety. It works on guidelines for the development and evaluation and standardizing the devices. The project Caresis is a prior EU-Japan collaboration, which is funded by MIC and EU. It addressed how robots can be culturally aware and answer user-specific needs in the environment, which is equipped with different sensors. The e-VITA project has recently started. It's a 3-year cooperation between EU and Japan. The main objectives concern prototyping of virtual coaches to sustain older adults' well-being in smart living environments, to develop norms and standards for interoperability, and to conduct proof of concept studies to assess user acceptance in real-life environments. There are more than 20 partners in the project, comprising of universities and research institutions, industrial partners, and societal partners. The coordinators are University of Siegen in Germany on the EU side and University of Tohoku on the Japanese side. The approach taken in the project is the socio-technological approach, which places elder adults in the center of the development. It brings together the different stakeholders in industry, community, as well as in research and education to design coaching technologies which can participate in everyday life of the elder adults and foster their emotional and social well-being. An important ambition of the project is to establish new socio-technological approaches for real-life practices for older adults. An overall e-VITA coaching system is shown here. Its functionality is expected to include support for social networking, physical activity, cognitive functions, as well as spiritual issues. Knowledge graphs form a central part of the coaching technology and provide a general data structure for the system knowledge and will also be used in dialogue modeling. Smart living environments provide sensor-based information, which is integrated into knowledge graphs. The upper part of the slide shows the interface agents which enable interaction with the user. This includes now the humanoid robot developed by SoftBank, and which is a common platform for studies in human-robot interaction in general, and Gatebox hologram, which uses 3D holographic structure to display the virtual coach. Daruma and Santo are the two spiritually oriented social robots, while the android has human appearance and sophisticated facial expressions. The sensors to collect data from the environment are X-Brain from the Noi company, which measures neural and emotional activity of the users in real-life situations, and Tixels from Delta Door sensing systems that can detect any moving human presence. As for the interaction, the dialogues will be based on constructive dialogue model approach and the RASA open system framework. The constructive dialogue modeling emphasizes 4 enablements for interaction: contact, to detect communicative signals and sense the presence of the partner; perception, to perceive raw signal as a meaningful signal; understanding, to interpret these signals in the context as conveying the user's intentions and topics they want to talk about; and reaction, to provide appropriate responses in the given environment. The enablements are mapped onto a system architecture and to different components which are responsible for interaction tasks such as signal detection, speech recognition, parser, intention recognition, dialogue state tracking, response generation, etc. The RASA framework is an open framework and its architecture is shown here. The core modules of dialogue management are the natural language understanding pipeline and a dialogue policy component. The system agent coordinates and controls the interfaces with the user through the input-output channels and to the outside world via the action manager, such as accessing database, showing a picture, and obviously making the robot move. When we map the RASA architecture on the CDM model, we get the architecture like here. The mappings between the I/O components and the NLU pipeline and the dialog manager are very straightforward, as well as the action manager. The RASA operates mostly on text, so speech requires integration of speech technology components to get the transcription of the speech signal as a string to the system, and similarly a text to be sent to a separate speech synthesizer. Special attention also needs to be paid on the integration of various modalities that will be available for the interaction management. The integration of dialog manager for the coaching agents is done in the general technological platform. We build on the 5-ware framework to integrate device-related components such as gateways, agents, and platforms, and data management APIs. This also includes interfaces for various system components which are responsible for data processing and interaction management, including natural language understanding and dialog manager components. Also, data-related AI components which are responsible for the data analytics, such as deep learning toolbox and knowledge graph technology. Given integration of the heterogeneous technologies and devices, an important part of the architecture design is to define interoperability inside the system and with the various interface agents. Since many smart living functionalities require storage of data as well as the comparison and exchange of data with other systems, the coaching system also needs to support security and privacy requirements for the different use cases. The system needs to comply with the European General Data Protection Regulation and the Japanese Act on the Protection of Personal Information, as well as the subject be able to manage their data and associated consents. Efforts have already started. For instance, the federated data structures and edge computing in the European Gaia-X project are examples of the work on the sharing of personal data between applications and components. With virtual coaching system, necessary standardization and interoperability guidelines can thus be developed further, building towards new advances in trustworthy AI. Finally, a few words about trustworthy AI. The main question is how to build reliable coaching applications and software. The issues deal with data sharing, especially between countries and continents, privacy awareness, that is being aware of the privacy issues when using such a system, and control and trust issues in federated data in smart living systems. Moreover, when the coach interacts with humans, also, ethics and data protection in the dialogue situation itself must be taken into account. For instance, what kind of information is delivered to whom and who is listening. It's envisaged that virtual coaches will go beyond the traditional role of tools to provide specific parts of care and coaching, and they become part of a bigger ecosystem where complex info is shared in federated networks. Such agents become boundary-crossing agents, and as I have argued earlier, they challenge us to recategorize the world around us, since such agents can interact and cooperate with humans. Boundary-crossing robots is a way to conceptualize the humanoid robots, which are not simply tools, but partners in everyday life. Maybe such boundary-crossing virtual coaches can facilitate interaction and help in mutual understanding between different viewpoints, thus creating trust and provide trustworthy operation. Finally, we'd like to thank our project partners in Japan and EU for wonderful discussions and collaboration. We also acknowledge financial support from the Ministry of Internal Affairs and Communication, MIC, in Japan, and the European Consortium received funding from the European Union Horizon 2020 program. If you have any questions or comments, I'd be happy to answer online or chat, and you can always send us an ordinary email. Thank you.